So by looking at the redshift of the spectral lines in light from distant galaxies, Hubble said that basically the speed of recession of that galaxy is proportional to its distance away from Earth. Now what that means is tomorrow the universe is going to be a little bit bigger because everything is expanding. That means that yesterday was a little bit smaller and the day before that it was a little bit smaller and so on. Now if we kind of take this kind of logical statement and we kind of follow it far back enough, eventually there's going to be a point at which the universe was very close together. And in fact, this is where we had basically a really small, a really dense and intensely hot point. And this is basically what we call the Big Bang. Now, the Big Bang happened here. It happened between my fingertips, but it also happened between me and you, and it happened inside the synapses in your brain that are allowing you to think about this at the moment. The reason is that the Big Bang must have happened everywhere. So you put your fingers together, and it's the distance between your fingertips where it actually occurred, because it created all of space and all of time. Now, I must say that this doesn't really make any sense to me. It's basically we follow a set of logical conditions, we follow them back, and what we get is something which is illogical. And I can't imagine how there was no time or no space, but that's exactly what happened. That's what we think happened at this point. So, what's the evidence for the Big Bang? Well, first of all, we have this starlight and how we've seen that redshift. That's one bit of evidence. But there's another bit of evidence which is due to the cosmic microwave background radiation. So in the early universe, when it was pretty small and pretty hot, there's a point after about several 100,000 years where we had transparency. And at that point, what we had was a huge amount of gamma radiation. So gamma has a very, very short wavelength. Now the thing is, as the universe, I'm just going to represent it here as a sphere, as the universe got bigger and bigger, this gamma radiation was stretched as the universe expanded. And as the universe kind of got towards its kind of current size, what we found was that the wavelength of what was originally the gamma radiation, I'll just draw it again over here, the wavelength of this gamma radiation has been stretched as the universe has expanded. And what we now have is something that has a wavelength which is in the microwave region, even though it started off as gamma radiation. So basically what we can do is we can detect these microwaves. But also, having looked at Wien's sort of displacement law, microwaves have a certain temperature. And what they have is a temperature of about 2.7 Kelvin. Or effectively, if you know the temperature, you can look at the intensity of the maximum radiation which is emitted. And basically this is because now the energy which was in the early universe where it was very, very, very hot, like really incredibly hot, effectively as the universe has got bigger, this energy has become more spread out, and the average temperature has gone down to about 2.7 Kelvin. So basically what we have is the cosmic microwave background radiation. And this was discovered in about 1965 by a couple of scientists. And what they had was a radio telescope. So here's my kind of radio telescope sort of pointing up at the heavens. And they basically tried to do some radio astronomy. But they kept on finding that there's a certain signal that kept on getting in the way. And, there's a story about them sort of thinking that this was maybe some pigeon droppings. So this is my pigeon. It looks like a chicken, I suppose that's going to have to be my pigeon. So they went up onto their radar dish, they cleaned off all the droppings, but they still found that there was this interference. Now this interference, it happened in the summer, it happened in the winter, it happened in the day, and it happened in the night. In actual fact, it didn't matter where in the night sky or where in the day sky they even kind of pointed their telescope, they always found that there was this kind of interference. And what they realised that this had a wavelength of about 1.1 centimetres, which then had a corresponding temperature of 2.7 Kelvin. And this is when Penzias and Wilson, the two scientists, discovered that actually just completely by accident, they discovered this radiation in the microwave part of the region that's coming from the sort of the background of the whole cosmos. And what they then had was they had the discovery that this radiation that they discovered had the temperature of about 2.7 Kelvin, which is what the theory predicted the temperature of space should actually be. So the Big Bang, it did happen. All the evidence we have points to it at the moment. And basically the two bits of evidence are the fact that we have galaxies moving away from us, and also that we can detect this radiation, which was effectively the stretched out gamma radiation from the early part of the universe, when the universe was very small. So I hope that helps, and I've got a few more videos now about really the whole evolution of the universe.